In this third video for Module 18, we consider erosion and transportation by wind. So we'll start with erosion by wind. And perhaps you've heard the term aeolian processes used to refer to wind actions. Not necessarily wind actions in arid landscapes, really wind actions anywhere. And this term comes from the Greek god of wind, Aeolus. So here he is. So one thing I might throw out is, how do wind and water differ in their erosive capabilities? We know water is a really important agent for erosion. We'll talk later about snow and ice, but how about wind? How does wind compare to water? Well, one might consider that water is 800 times denser than air. So of course water is a better and more effective agent in erosion. But that doesn't mean that wind doesn't accomplish some things. We can say that wind is mostly limited to the horizontal movement of air. There are some vertical movements, I suppose, of air that we might consider, but it's we look here mostly at wind as a horizontal movement. Now, a couple things to consider when we look at the effectiveness of aeolian erosion. The erosive force of wind increases exponentially, so we can say that a wind velocity increase of or up to 4 meters per second leads to an 8-fold increase in the erosive effectiveness of the wind, and 10 meters per second, a 125-fold increase in the erosive effectiveness of wind. So just even a small increase in velocity makes a big difference in terms of what a wind can do. Can remove where it can remove material and carry material. Let's talk briefly about some forms of wind erosion. We're going to look at two. One is abrasion, and that's just where the wind is picking up and entraining particles of sand and then just pushing them up against objects. And the wind's effectiveness in eroding those objects is enhanced by picking up, for example, the sand and sandblasting the side of something. So we call that abrasion. And the second is represented just where materials are picked up and carried away, and we have a void that's left behind. And we call that deflation. So look briefly at abrasion. Here's some examples of pedestals in northern Arizona. Maybe you've seen some of these if you've traveled in some of the areas of some of the western states. Here you see sort of a pretty tough caprock, and then this material below that's been hit pretty hard. The wind doesn't necessarily pick up to such an extent that these particles of sand that aid in erosion are really carried very high. They're usually pretty low to the ground surface, and that's why you see most of the erosion happening here at the base of this rock that's been converted into a pedestal. Here's another example. This is called a yardang, and again, this was a rock at one time that was more symmetrical, and now because most of the wind erosion really focuses here at this lowest level of the rock, it just has an unusual look. Here's another one. Really crazy looking pedestal. So you can sort of imagine that the wind isn't really picking up sand as that sort of sandblasting material, and it's really not going very high in elevation at all. So most of it's hitting the low-lying parts of rock. So here's sort of a cutaway view, from a side view, if you will, of wind removing material from a rock. So this is not that different from if you were at a high school, for an example, that had a problem with graffiti, where a lot of graffiti was added or applied to walls and other structures, and somebody had to come along and sandblast to try to remove the graffiti from an uneven surface. So they couldn't just sand the surface; they had to blow either dry sand or wet sand against the graffiti to try to remove it before they repaint the surface. Ventifact is an example of a rock that's shaped through wind abrasion. So with this ventifact, you can see if this sat for a while in an arid area, in a desert, if you will, we could probably say that there were two prevailing wind directions that helped to shape this rock. So the rock started out nice and round. The one side of this, along this fin here, where it's sort of an edge, would represent one direction of the wind blowing, and then maybe seasonally the wind changed direction. It came from another direction. So perhaps from one direction might be from the southwest, one might be from the southeast. These grains of sand have been wind blown, and sand, just like anything else, like river rock or pebbles at the beach that become rounded over time through abrasion. Same idea when sand has been involved and been carried by the wind and been pushed up against something or those sand particles have come in contact with each other, they tend to become rounded over time. Here's some wind abraded tree trunks. So it's not just not just rocks that are affected by abrasion, living things as well. The other type of erosion that I wanted to mention, aeolian erosion, is deflation, and that's just where you might have material just picked up and carried away in a big void left behind. So this deflation hollow has been created by wind that sort of got in there, kind of got into this hollow area, and removed some of the sand and carried away the smaller, lighter particles, left behind maybe the heavier stuff in this hole. And here's another called a blowout, sort of a big example of deflation where material has been removed and carried away. And one more example of a blowout. So, all right, and to look at sort of an extreme example of a blowout where deflation is taking place. The Qattara Depression in Egypt is sort of an amazing place. It has quite a bit of the Qattara Depression is below sea level, so materials have been picked up and carried away. And this is a place that is located in Egypt. Just to show you a comparison of depths, much of the depression is at around 133 meters below sea level. So in comparison, we have the Dead Sea in Jordan at about 1,200 feet, or about 400 meters below sea level. But look in comparison, the area that's below sea level, we have about 3,800 square kilometers around the Dead Sea of Jordan. In the Qattara Depression, 44,000 square kilometers. And this place is only located about 56 kilometers from the Mediterranean, from an ocean. And here's the location. I've sort of circled it here. This is Egypt, and just above this red circle would be the Mediterranean. So here where I'm pointing would be the Mediterranean, and that's the depression you're looking at in the photograph. A little bit about aeolian transportation, so the movement of materials by blowing wind. It happens in a couple of different ways. If some of the terms I'm going to use seem similar to when we were talking about in another video about what happens with fluvial erosion in rivers, we use some of the same terms. So when materials are just carried along by the blowing wind itself, just by the velocity of the blowing wind, we refer to those materials as being carried in suspension. So it takes a pretty high wind to entrain those particles, but if they're just carried along by the blowing wind, those materials are carried in suspension. So it would be an example of a dust storm affecting some U.S. troops at a facility in Iraq. Definitely an example of materials being held in suspension by the blowing wind. We tend to see that sort of the aftermath of materials being carried in suspension. The materials become similar to this left-hand view here. Well-sorted materials are wind-blown. They're often of similar sizes. So if you see a bunch of stuff, sandy, gravelly stuff that's of similar size somewhere, it's very likely that it was wind-blown if the particle sizes are similar. If you see particle sizes of varying sizes, the chances are that you're looking at some particles that have not been reworked by the wind, if they're different sizes, so they're not wind blown. There are a couple of terms I thought I'd mention. In order to entrain particles, you have to reach something called the threshold velocity, so it's sort of a minimum speed at which sand particles will be held in suspension, or dust particles, or any particles at all. And then those particles will stay suspended until they reach the terminal fall velocity. So we could say the terminal fall velocity is the speed at which particle being transported falls and is deposited back on the ground. So those are sort of both two extremes in terms of either carrying materials or not carrying materials. And just to give you an idea of some sizes of materials and also the velocity of wind that might be necessary to entrain or carry those particles in suspension, here's some examples. So really fine sand might be carried. The threshold velocity might be just 10 to 15 miles per hour. Something a little bigger, maybe something that was nearly a millimeter in diameter, like this sand particle that I show in the upper view, might require a stronger wind to be carried, to be entrained, 18 to 21 miles per hour. And then, of course, even bigger stuff like this 2 millimeter gravel particle, that's going to probably require a threshold velocity over 30 miles an hour to remain held in suspension, carried in suspension. This is a dust storm off the coast of the Sahara, off the coast of Africa. You can see Morocco right here, where I'm pointing, south of Portugal and Italy. But these are Passat winds from Africa that are sort of carrying this. It's sort of a easterly wind from that easterly band of winds we've talked about a little bit previously that blows, and this is carrying sand well out to sea, well out into the North Atlantic Ocean. All right, as I mentioned, some similar terms to the ones when we talked about what happens with fluvial processes, where you have slightly larger particles that may be too heavy to be carried in suspension, sort of bounce along the bottom or bounce along the ground, if you will. We refer to that as saltation. So saltation, they have sort of a bouncing, maybe picked up for a meter, set back down, picked up again, carried another meter, set back down. So we call that saltation. Traction is where materials are pushed or rolled along the surface by heavy winds. It may take a while for something to be rolled in traction, but that usually refers to the heavier materials that are too big to be carried in suspension or picked up for short distances in saltation. And then creep is the process where the whole surface of the ground moves. So creep is where you have this, the whole surface seems to be moving in response to the blowing wind. A couple things about aeolian transportation. Here we see some sand dunes, and notice the sand dunes that I've drawn. These are side views of sand dunes at different positions. So we see the windward side here of the sand dune is where I'm drawing these arrows that represent the wind, and we see the net transport of sand. It's almost like a conveyor belt action. So the wind is blowing on this windward side, and then the sand particles are being pushed up this sort of gentler side of the sand dune. Or what we call the windward side of the sand dune, up to the top, up to the crest. They hit the angle of repose. You might remember that when we talked about mass wasting. And then those sand particles will sort of slip down on the slip face, on that steeper slip face. They'll start to slide down. And this causes the whole sand dune to move over time. So it kind of moves like I say, like a conveyor belt, like a massive conveyor belt with sand that just sort of climbs up one side and slips back down the other. We can see that in this little animation. Again, we have the windward side, always on the side where the wind is blowing from, the leeward side, steeper side, and then the slip face, where the sand sort of transported up to the top, they hit the angle of repose, and then they sort of begin to sort of slide down the backside. This is the slip face, viewing it dead on. So we're standing on the leeward side of the sand dune, so the wind is coming from the other side of this dune, and it's pushing it up over the crest of the top, and it's slipping back down on this side that's away from the wind. And to put it all together so you can see all of these different transportation methods sort of together. We've got, this is a side view, we've got our sand and lighter particles of perhaps silt carried in suspension, and then we have saltation that's carrying those bigger pieces. Maybe they're picked up for a meter or so and set back down. And then we've got traction, rolling or sliding of bigger particles, and the whole surface moving together, referred to as creep. And look at the distance here. We're just talking about, for saltation, it might just be, an inch or something like that, or a few centimeters. Not really, these particles aren't really rising up very high unless you have a really strong wind. And I thought I'd show this. Dunes can actually climb over things. These are climbing dunes, both in the Mojave Desert. But this is the backside, the leeward side of a climbing dune. So the dune is literally climbed up over these rocks, and it's coming back down this other side. This other view on the right is a dune that's sort of going up over this mountain range. So sort of remarkable to think that dune sands can climb over mountain ranges.